Okay, one of the things that I talked about, so last time we saw the hello world example. So one of the things I'd like to do is actually show you an example where we actually declare a number of different types of variables and also initialize them. And we'll see some input and output as well. So the first thing I want you to do here is go in your text editor and create a new file. We're gonna save this one in your case, I'm going to save it in my desktop CSCI 1060U folder, but you're going to save it in home/CSCI 1060U. So we're let's call this one hello double, because we're going to look at the double type. So in here, what's the first thing that I need to do when I create a program? What's the first thing? We have to do things from scratch. Someone call it. You don't have to always put up your hand.
Find the entry point.
Something more simple than that.
Include libraries.
Include libraries, right? In terms of what shows up in the file first. So what libraries will we need to have here? So we're going to want to in here iostream. Do you want to use iostream for input output for now? Is that okay? Let's leave that. We'll add some more as we go. And we also want to specify that we're using specify the standard namespace. And we do that by just saying we're going to using namespace std. And then we're going to just we're going to do things for now in a main function because we haven't learned about anything else. Typically a main function has an int as a return, so you typically put return 0 at the end. We'll see later in the course instances where we may actually want to have this actually return something. But for now, this is just sort of where we usually start from. Okay? And one of the things somebody asked me earlier about, so if we're actually want to compile, somebody asked me about errors. I think it was you, right? Yeah. So if we actually go in here and we look, now we've got this hello. Did I save it as hello dot double? Okay, that's fine. So right now, if we actually compile this hello dot double, it compiles fine. Okay? And if we wanted to, we could actually go do the same thing. If we want, right now it saves it as the a.out file, but we could also specify hello double as the name of the output file. And now if we list, we see there's also a file called hello double here. How do you know if a file is executable, by the way? Anyone know?
The color of it changes.
Sometimes it depends on your terminal. Sometimes the color will change, but I use this ls command, which is short for list, when I'm listing files. If I do a -a, that will list all files, including hidden. If I go ls-l, that will actually give me a more detailed version in tabular form. So it gives me information here. And one of the things it does is it tells me, this is about Linux a little bit, but it tells me who owns the file. In my case, I'm Jeremy Bradbury, your professor, so J. Bradbury. It tells me the group that owns it, and it tells me when it was created, and it tells me the name. And up here, though, it tells me what I call the permissions. So the first thing it does is, this first symbol will just let you know if it's a directory or not. It's empty if it's not. Then it gives you what's called user privileges, i.e. what can the user, the creator me, do. It also gives you group privileges and world privileges, meaning what anybody can do. So the only thing you really need to know is that there are 3 types of privileges. The first type is the ability to read the file. That means you can open this file and view its contents. There's also that's represented by an R. There's also W, which is write privileges. That means you can open the file, also read its contents, and modify them and save them if needed. Does that make sense? The last type of privilege that you can have with a file in Linux is what's called executable privilege, meaning the file can be executed as well as read or written in this case. So you'll notice here that the a.out file as well as hello double are both executable by myself, by anybody in the group, and also by anybody who uses this computer. Okay? So this means, so we can tell what the executables are simply by checking if they have that executable privilege. So that's if you type ls-l. That's just a little Linux comment. It's not something that's necessary for the course, but since we're programming in Linux, those are the little things that you might find helpful as you learn. Another thing is, I'm going to use this command every now and then. If you see that the text disappears just because I have a smaller window, you can always type clear and it just gets rid of all the old commands. If you use the up arrow, you can actually cycle back through the commands you ran. So if I want to, for example, compile this file again, I don't have to type it all out. I could just go back, use the up arrow to get that command. Do you guys all see that works? How many of you are following along doing this with me as we go? Okay. Those of you who aren't, are you still being able to follow on this? Okay. So one of the questions that got asked was, what happens if there's an error, right? So one of the things that we want to do today is we're going to use this example just as an introduction to how to declare and initialize and work with variables of different types. So for example, we have a double. We're going to create a double x, and we're going to set it equal to 2. Okay? If we go now and we compile this, it compiles. Now, an example of a syntax error that we could have is what if we forgot the semicolon, right? That's something you can do, because a semicolon is needed at the end of every instruction, every statement. So if we try to compile it now that we remove the semicolon, we're going to get an error. And what it does is it actually is really good, because it actually tells us, hey, this is exactly where the error is. In the hello double.cpp file, 817, what does that refer to? It refers to line number 8, position number 17, character 17, which is right here. And it tells you exactly, it even says, it expected a semicolon right here at the end. So it pretty much, not only does it tell you what file it's in, what line it's at, what position the character is, it also tells you what the error is. So that's just an example here. Now, one thing that might be useful is we want to use the cout command to display this. So the way cout works is, cout, you use the cout command, and it says basically everything on the line after we're going to do a cout. So we do a cout, and we do these 2 angle brackets, and then whatever we put after that, like x, will be displayed out. So if we go cout x, this will actually, if we compile now and run this, using a.out, we will see that we got 2. Not very helpful, is it? At this point. What's one of the things that annoys me about this is that the 2 here is showing up as the same line as our command line. So one of the things we can do here is, on this cout line, we can also put something called endl. And that's a special name, a special keyword that goes along with the cout, which allows us to then put a new line after this. So we can go cout end line, and if we compile this now and run it, the difference is the 2 shows up followed by an end of line character. And every time we display something out, we use a set of these angle brackets to separate them. Yes?
When would you use endl versus
/n? /n you can also use. So there's an alternative to this, which is the same thing, where you could actually do this. This means the same thing, right? I typically find endl works. It's a preference thing. I like endl myself. I only use the /n if I have a string of characters. So what we're going to also do is, just displaying x isn't that useful. So what I'd like to say is x equals, right? So I'm putting the string x equals x. So this is going to say x equals 2. And if we run this now, compile it first and run it, we get x equals 2. Now, what do you notice is a problem with this? How does it display it out? It displays it out as the number 2, but how do we enter it? We initialized it. 2.0. This is fine because it turns out 2 and 2.0 both are the same thing, but it may be that we want to have decimal places shown. Maybe we want to show to 1 decimal place. So there's a couple of ways we can do that. But one of the things is we can actually set some preferences here, and we can actually here, if we want to output doubles with 1 decimal point, right? With 1 decimal place, we can actually do this. We can go cout. We're going to say it's fixed, and we're going to say set precision to be 1. Okay? So fixed point, set precision to be 1. So what this is going to do now is, if we run this, oh, why didn't it work? What did I forget to do? Yeah, I forgot to compile. So you have to actually remember to compile. Oh, what happened here? Set precision didn't work. Why didn't it work? Right. So it turns out I didn't include the right library. I only include IOStream, which allows me to do input-output. But there's another library which we're going to want to use here called Manip. And this one is actually a library which includes commands like set precision, which allow you to manipulate how you want the input and output to be displayed. So if we now run this, we can actually see that it works. And just a little comment here about the error. It says use of undeclared identifier set precision. If it doesn't recognize something, it means either you didn't include the library that that's part of, or it means that it's something that you meant to create, like you used X here, but you forgot to declare it. So either you haven't declared it in your program, or you haven't included the library for it. Yes?
Can you just like set the main as a double, and then whatever numbers you input that pop up?
You could. We'll see that in a second. So, sorry. So let's actually now compile this. It compiles, and if we run it, what do we get? 2.0, right? So far, so good. So, what about if we wanted to have all of our output be 2 decimal places? It turns out if we actually created here another double, and we can also initialize things like this with an expression, 4.0 divided by 3. What does that equal? 1.33 something, right? So if we actually wanted to, we could display out y here. Like this. And what will y be in this case? What should the output of this program be? Yes. 1.3. So it'll be x. First, we'll still see our x equals 2 and y equals 1.3. It turns out when we did the set precision, we actually set that for the whole program, for cout. So if we, for example, later did let me just adjust this a bit. So if we later did something similar where we did double z equals what? Anyone know what this one is off the top of their head? So if we did this, and then we also did a cout if we wanted this to be 2 decimal places, we could take this line here, we could actually just go down here, and before we run this, we could actually change the precision to be 2. And now everything that's after this point will be of 2 precision. So if we compile this again and run it, we now see it's 4.62. Does that make sense? Great. So I guess there's a couple of other things. Let's actually change this a bit. What if we did this? What will the program be now for Z if we do 10 divided by 3 here? What? What will be displayed out here? So remember, it's 2 decimal places, so it would be what? 3 point, what did you say? 3.33. Who agrees? Got some hands up. Anyone disagree? Yeah? Why?
3.34.
3.34? You think it'll round? Okay. Any other guesses? 3.00? Anyone agree with that? 2 hands, 3 hands. Yeah? 3.33, you agree with him? Okay. Here's the thing. How many of you who have said something actually tried this? Okay. So, out of the people put it in, 1 person tried it, which is great. What I'd encourage you to do is, when I ask these kinds of questions, you've got your computer. Try different versions of the program. See, and if you're somebody who is a little bit more advanced in terms of what you know with programming, you can also use the time to try things yourself. And then you can always ask questions if there's something that you find interesting. Okay? I'm happy to answer those questions as well. So let's actually see if you're right, if it is in fact going to be 3.00. It is. Now the question is why? Yeah.
They're both integers. They don't have a double.
So these are both integers. So what?
But the integers, they don't have a double format. So they won't be anything after decimal.
So what you're saying is, what he's saying here is, when we had this here, 4.0 divided by 3, okay, that operator, the division operator, works differently with floating point than it does with integers. Remember I talked about this earlier? So in this case here, the floating point division works, so it goes 4.3 divided by 3, and it preserves, it says that's 1.3, 3 whatever. So it does floating point division. In this case here, where we have 10 divided by 3, 10 is a what? Integer. 3 is a what? What happens when you divide one integer by the other? It uses what type of division? Integer division. So what's 10 divided by 3? It's 3 with a remainder of 1, or a modulus of 1, right? So that's why we get 3.00 here, is it takes an integer, divides it by another integer, and gets 3, which will then actually get stored in Z. So that's just a little bit about how to declare and initialize variables that are like doubles or floats or whatever.